Okay, so this should be correct. So we were, can minimize that one. And I think so. This one is very short. RSA continued. I just have a few notes in here. And then after that, we've gone over the slides and the terminology, and we'll just look at getting into the actual details of the algorithm. All right, so RSA, right? So okay. So RSA, Rivas, Shamir, and Edelman, that's the name. The RSA encryption scheme provides asymmetric public key encryption. And this is just kind of summarization of the algorithm itself. So we're going to go we're going to look at all these details, okay? But this is just kind of a one shot of this. So the public, remember, there's a public and a private key in RSA. The public key consists of two large integers, which are E, comma, N. So actually, the public key is made up of two things, okay? E and a tuple, basically, of E and N. And the private key consists of two large integers, D and N. Notice that they have in common N, but D really becomes the private exponent, as it's called, and that you should not share with anyone. But usually, when you store your private key as a file, you store both values in the file, okay? And then when you make available your public key, you make available E and comma N, so two values, okay? So that is, so the public key consists of two large integers, E comma N, and the private key consists of two large integers, D comma N. Note that the second number N is the same for both. The three numbers E comma D comma N are related in a special way, math, which requires a bit more mathematics to go into, and we'll go into this. And it's actually not like, it's algebra. It's almost like very simple in a way. So you guys will see that there aren't really that many complications. Obviously, what we're looking at is the algorithm itself, okay? Oh, there it is. Okay. I think it's working. The crucial point is that N is guaranteed to be the product of two prime numbers. Okay, so we'll see that. So really then, we're going to have to select two prime numbers, P and Q. Okay, and we're going to multiply them, and that becomes N. So N equals P times Q for two prime numbers, P, comma, and Q. If you know E and N, and you found the factorization of N into P and Q, you can compute D easily. And this is one of the things that we will see. This is how you break RSA, okay? So, but basically it's very difficult to do. So the security of RSA requires that factoring a large integer should be difficult or next to impossible, and it is, right? So the values are very large. Today, RSA implementations might use 4096-bit number for N, so it's really large, okay? Nobody currently knows how to factor numbers of that size quickly, which is to say before, we or the planet are long dead. So it takes a computer a very long time. As I will show you when we look at factor DB, if these values are small, we can totally factor, and get P and so given N, it would basically give us P and Q. If we have P and Q, we know everything, okay? So the idea is that N would be so large that when we put it on the website of factor DB, there's no way it can tell us P and Q, basically. So nobody, so RSA seems pretty secure. However, nobody has proved that it's impossible to factor numbers quickly, large numbers quickly either. So RSA may be broken someday, or it may have already been broken by someone, right? That's a possibility. If you're, a government and you've broken RSA, would you tell other people? No, right? I mean, you're going to use it to your advantage. Yeah. And so no one really knows, right? But if somebody broke RSA and made that knowledge public, they would cause a serious impact to society in general, right? You can imagine, your bank is no longer secure. I mean, think of hackers, right? And people that do malware and stuff. If they knew how to break RSA, they'd do even worse things. Got it? Does this make sense? All right. So we'll get, obviously, these are just some statements I'm making right now. But we'll drill down into a lot of these details. Here's a little joke I found that I thought was, fun. So you can see it's so hard to break RSA. Just hit the person in the head with a wrench and get the password. Might be easier. Right? So, but that's the idea. All right. So I found that one. Yeah. So that's kind of basically the slides. Okay. And to kind of give you some general ideas. And then in the rest of today, we'll drill down now into the algorithm, the specifics. And then, of course, we'll start coding this up in time. Okay. So we're done with the slides. So I'm going to switch to the whiteboard and just kind of discuss. Give me a second here. All right, so as you can see, we are in this module RSA. Basically, the notes that I'm going to give you now are in these PDFs. So you can use those as reference. We've covered the 2 PowerPoints. And then this is the lab on Thursday. So you can not have to worry about that one. All right, so now we're going to move on to details of RSA. So let me, this recording.